This is my 5th class, the 3rd session, 2 hours. I'm supposed to do today a fairly major amount of work. You have to pay very high attention because this is a complex. This is the real solar DC, powering residential and business sectors using solar DC. So let's start with the understanding of power cuts in India, or load shedding. It's more commonly called load shedding, and solar DC solution and the UDC innovation. Am I covering both solar DC as well as UDC? Okay. Now, power situation in India, a large percentage of homes are not connected on the grid. The actual number is not very well known. Some reports show that it is about 30%. Of course, more recently the government is sort of saying no, it is not that much, but we don't have authentic data. We don't know whether it is 30% or 20% or 18%. It really doesn't matter. 18% of 250 million homes is still 40-50 million homes. So very large number of homes. And basically what happens, what we have found, particularly while we are working in Rajasthan, that capital cost of laying a line all the way from where the power station is, where the substation is, to the home, you require a certain capital expenditure, and capital expenditure of course need to be both depreciated, and interest cost of that has to be taken into account. Then you need to take into account the maintenance cost, the recurring cost. Recurring cost includes maintenance cost. There is, whenever you send power through lines like this, there are losses. So if there are losses, and what you are sending, if there is a large losses, for example, if 30% is lost, the 30% power is also, or 40% is lost, that 40% is also extra cost for the distribution company. And finally, if it is a scattered homes, few homes, collection of bills. What if they don't submit bills? Even reading of meters, all this becomes a very big cost. And they finally find that cost is many times more than what the average bill is likely to be. And that's the time they sort of say they are not interested. If somebody forces them, they may try to do, but generally even if they put it, they will not maintain it, whole thing will go off, almost offline. So that is the current situation why large number of homes are still offline. So these power cuts or load shedding, it can be 1 to 4 hours, that's fairly common. If any of you are living in Bangalore or Karnataka, power cuts have been very heavy. This year, 3 years back, Chennai and Tamil Nadu used to have power cuts of 12 hours, 14 hours. Power cuts vary from place to place around the country, but power cuts take place pretty much all the time. Then load shedding. Now what is this power cut? This load shedding I am talking about, this is not because of a fault, because the amount of power available is less than the amount of power required. So therefore what you do load shedding in select areas, and that's how you balance the supply demand. And this load shedding 12 hours is very common, and you go to villages, it could be 16 hours, 18 hours, 20 hours. Many of the places are connected on the grid and never get power. So it's a 24-hour load shedding. So you need to take all this into account. What is the problem is, what are Indian homes capable of paying? Now, let's take homes which are earning less than 5,000 rupees per month, 4,000 rupees per month, 5,000, and that's very large percentage. Earning 5,000 rupees per month, I don't have the exact statistics, but my guess will be almost 50%, 40%. How much will they be willing to pay? 2,000 to 200, 250, 150? The homes which are 10,000, okay, will be willing to pay maybe 400 or something like that. But even there, they will find it difficult. So it's a low ability to pay. In fact, most homes are not willing to pay more than 100 to 200 rupees per power. That's the situation. You go to even Chennai, I'm not even talking about some remote areas and all that. Go to a city and you go to slums, what people are willing to pay? 100 to 200 rupees, maybe 250 rupees. And that because their incomes are only so much. And that's a very low ability to pay is a very important. And that shows up. If I take last year's domestic consumption, it is a 200 terawatt hour per for the 1.25 billion people. 200 terawatt hour. 200 into 10 to the power 12 watt hour, or 200 into 10 to the power 9 units, kilowatt hour. If I divide it, it comes out to be 500 watt hour per day. Divided by 365, 500 watt hour per day. For per person, you divide it by 1.25 billion and divided by the 365, you come to less than 500 watt hour per day. And if you take even 5 people there in a home, you are talking about 2.5 kilowatt. So that's the average consumption of power today in India. 2.5 kilowatt hour in the whole day in 24 hours. So if it was uniform, you are talking about using not more than 100 watts. Just imagine, this is the average consumption. Now this is very important because as we start doing various things, we will see, in fact, that causes a serious problem. So even if I take the 30% or 33% are disconnected and only the 67% are consuming this, it comes to 4 kilowatt hour a day. So 4 kilowatt hour a day, what will the peak load be? 100 to 500 watt. That's a kind of peak load will be there. Most lower income homes will consume less. This is the average. Average taking off the 33% who are not connected. So most lower income homes will connect, will consume less. Some upper, what happens when power fails? If it is upper income groups, you can check with at your own home. If you stay in a multi-story complex or you are upper income group, you can turn on the diesel generator. That happens. A typical cost of grid power is 5 rupees per unit. Can be less, can be slightly higher. 5 rupees per unit. Typical cost of diesel generated power is almost 5 times, 25 rupees. But we are willing to pay if power cut takes place. Those who can afford to pay will rather live with power and do that. And many homes, I know many Chennai homes have that. When power cut takes place, Bangalore homes I'm sure have. What do the middle class and the lower middle class do? This is the upper section. It's 25 rupees per day our people cannot afford. Some mid and lower middle class who do not have this complex, and therefore that 25 rupees also happens only in the complex, not in a single small homes. So it will take, they use what is called inverter. So all of you know inverter, and we will discuss about the inverter. Inverter is a very, very important thing, and cost of power is even now. If you take total cost of power, means cost of charging the battery and taking the power out of the battery and using it, is still 4 times the grid. Why? Because battery is very expensive. We'll look at some of these numbers. What happens to others? Others just suffer without power. So what happened? What is the inverter? How are the inverters designed? A typical inverter, is this okay or not okay? I should only use this. So if your typical inverter takes a 230 volt AC input, put an AC to DC converter and gets a 48 volt DC, typically 48, sometimes it could be 24 volt, but a typical inverter could be 48 volt DC, AC to DC converter, charges the battery and takes the power out of the battery when power fails, and do a DC to AC converter and get 230 volts AC. A very relatively straightforward concept. So there is AC to DC converter along with a battery charger, essentially battery charger. So the actual voltage here will depend on what is the what is the state of charge of the battery. You have to design appropriate battery charge. If you do a poor job, you lose a lot. So typically you not do a 48 volt, but more like 50 to 54 volt to charge a battery. And of course battery can be 12 to 4 volts, so appropriately numbers will come down. On power out, you take the power, power from the battery, convert it to AC. Now battery charge discharge rates are limited to 10% of its capacity. And I am taking the lead acid battery, or also called VRLA battery, which is the most commonly used battery in India. Now, what is the battery capacity? Battery capacity can be a 5 kilowatt hour. If it's a 5 kilowatt hour, your charge discharge rate typically should not exceed 0.1% or 10% of that. So about 0.5 kilowatt hour for a 5 kilowatt. The reason is, if you do higher rate of charge discharge, if you do it faster than that, then the life of the battery gets very badly affected. So 10% is very common you can go to 15%. Above 15%, VRLA battery will certainly lose. In fact, the many time battery management says keep between 5 to 10%. So that's a kind of thing. Now, what are the losses? There's a losses in AC to DC converter. There's losses in the battery because you are converting electrical energy into chemical energy, and there is a losses in DC to AC converter. So if you are large, like if you had a charging rate of 5 kilowatts, charging rate of 5 kilowatt, then the losses are only 5%. But for charging rate to be 5 kilowatt, you have to have a 50 kilowatt battery, 50 kilowatt hour battery, and hardly anyone has that. If on the other hand charging rates are 100 to 500 watts, even a 500 watt will mean a 5 kilowatt hour battery. That's probably the maximum that you will have it in your home. The losses can be 15% or higher. So your 15% losses here, 15% losses here, plus 10%, your 40%, probably a little more like 45%. That's what most inverters have. Why? You are not going to discharge at more than 500 watts. Because your battery may be limited to 5 kilowatt hour. At 500 watt, designing a efficient AC to DC converter is expensive. Either you pay a huge amount or just accept the loss. Similarly, DC to AC converter, inverter design, better than 15%, cost will either go up tremendously. So you accept this 15% losses, 15% or even little higher than that. So most inverters that you get in homes have something like that. So what happens? 15% plus 15% plus 10%, 45% is lost. Maybe you take other losses, maybe more closer to 50%. So only half of the power that you start with and your battery is filled with is available to the load. So that straight away impacts your thing. Now, this is at 500. At 100 watt it will be even more difficult. Try to take it as a challenge. Can you design a 100 watt AC to DC converter from 230 volt to AC? Take it as a project. Excellent undergraduate project. 230 volt to 48 volt AC to DC converter. Very simple thing you will say. 100 watt only, so not very large power. Let's have losses less than 10%. Tough to design. You can design that. Remember that you can design that. It will become very expensive. If you allow 15 to 18% losses, it will be relatively less expensive, and you want it a small fraction of your battery cost. So your battery cost of 1 kilowatt hour battery is 6,000, 6,500 rupees. You want your charger discharger circuit to be not more than should not be more than 2,000, 2,500 rupees, both of them. So in that case, your losses will be at least 15%. If you are willing to spend another 10, 12,000 rupees, maybe you will get that advantage. And I'll put you as good design. Good power electronics design is going to make a huge difference. So take on the other end, now let's take rooftop solar PV. All of us know that I can put solar panels on my rooftop. Today everybody is talking about without understanding anything. Governments are putting subsidy. These are all driven by the companies who wants to sell solar panels. Nobody has bothered to understand things in Indian context. But let's take a solar panel. Take a solar panel, 500 watt, 250 watt solar panel, and let's connect it. What happens? You want to connect it to 230 volt. You want to mix it up with 230 volt. I'm not even talking about power feed. Leave the what is called reverse feed. Let's take only the one side feed for the time being. So there is an inverter. There is an inverter. 230 volt is coming in here. This is coming in here. You have to of course have MPPT. Remember in the last class I had told you that if you don't design a MPPT, you will lose a lot of solar power. So maybe in the inverter MPPT is also built in, and then you get a 230 volt output, which is a combination of solar plus grid power. That's what is needed. But there are equipment available. You can buy off the shelf, buy a 250 watt or a 500 watt solar panel and buy an inverter. Grid synchronize it to 230 volt only for one directional, and then drive your power. So whatever power comes from solar panel will be used. whatever remaining will come from the grid. No reverse feeding, so we are assuming that solar power will be always less than what is being used at any instant of time. Now, if it is an inverter, if the panel is 10 kilowatt or more, you can get these inverters at 97%, 96% efficiency. If it is 100 kilowatt, you can get it even at 98%. What happens if the solar panel is 200 watts, 250 watts? That's where the problem is. Once again, design this with synchronization at a somewhat ordinary cost. Losses are at least 15%, if not more, at least 15%. Remember, what's the cost of a solar panel? If it's 100 watt, it's typically around 5,000 rupees. Maybe with installation 5,000, 6,000 rupees you can take. Well, with inverter maybe 6,000. 5,000 rupees if you take a solar panel. 200 watt is about 10,000 rupees. How much are you willing to spend for inverter? Maybe 4,000, 3,000. You're not ready to spend 30,000 for inverter. If you are willing to spend 4,000 rupees, you will find that you will get 15% loss. Minimum. You will get probably larger loss. And I think that's a problem. In India, you are going to spend small solar panel. Because what your average consumption I just showed you is not that high. Therefore, you are going to put a small solar panel. If you put a 10 kilowatt solar panel, upper section who have a lot of money can go ahead and put it, then problem is much less there. But then that is a 2% or 1% of India's population. If you are not talking about doing technology only for the 1% of population, then we face this problem. They will be able to put in, you tell them 20,000 rupees, maybe they will be able to invest for the panel, for the inverter, for combination of everything, they will be able to do that. That's a typical, that even a middle class home can do that if it helps, but that's where the 15% losses come. Now, the next question comes, can it help me? Therefore, if I put solar panel, will I not be impacted with power cuts? No. Why will it not be impacted? Yes, solar can feed power and grid will also feed it. If grid goes away, first of all, today's inverters are badly designed that if grid goes away, solar power gets shut down. Why does it get shut down? It gets shut down because, solar panel power will be varying and your load is going to be not clear what your load is. If you don't have grid, then the source power and the load must match every instant of time. Very difficult to do that. If grid is also there, grid plus solar is going to match the load. Then there is no problem. Whatever solar can give you, fine. Whatever remaining can come from the grid. But if you don't do that, then first of all, the grid and the solar has to match. The solar and the load has to match exactly, and that's not easy to do. So what happens? All the inverters are designed. The minute the power goes off, this also cut off. So no power takes place. So that doesn't help at all. What is sometimes done is that now if you put a battery, the problem is not that much there. You put in a battery and charge on the battery and then you take off from the battery. Then there is no problem. You can actually do that. The problem is if you are going to take an inverter, you have 15% loss, you have got AC, 230 volt AC. Now you want to charge the battery, you have AC to DC converter, another 15% loss. Then you take power out of the battery to drive your load, you have another 15% loss. Plus you have a battery which has at least 10% loss. The minimum loss that you are talking about is 55%. In reality, more like 60-65%. So whatever solar panel, you may have put a 200 watt solar panel, even if it gives you in the peak hour, let's say 200 watt, what you are getting is only 80 watts. Most of the power is wasted. And most solar vendors don't tell you that. Most companies want to sell things, it doesn't. So what can you do? Can you do something? Well, you can design better inverter. If it's a larger panel, if it was a 10 kilowatt panel, you could have got this at 97%, 96%. This could have been also done at 5%. This could have also been done at 5%. Your losses would have been only probably 15% overall. Plus battery, 10%, 25%, you still would lose things, but at least it is manageable. Maybe 20%. You can overall reduce it to 20% if you do 10 kilowatt. Of course, it will become expensive because batteries will be expensive, solar panel will be expensive. All these inverters and AC to DC, DC to AC converters will be expensive. But if you are, that is for large home, for really large home. For corporates there is no problem. But if you are, for your institute, if it wants to do, no problem. But you want to do it at your home, you will do half a kilowatt, 1 kilowatt maybe, and that's where the problem will come. There you will not be able to design anything with less than 60% losses. What will sort of say, can we do some better design? For example, earlier if you see, grid and solar would now charge the battery and also supply AC power to the loads. During load shedding, solar and battery will feed the load. When solar is not there, grid alone will supply the load, and if now grid fails, battery will supply the load. So this is all fine except for the losses, but the solar solution has serious limitation. First of all, solar photovoltaic power costs similar to grid tariff, but introduction of battery increases the cost. I just now talked about 4 times. So solar, which looked very attractive because solar is same cost as grid, suddenly by introducing battery you have lost anything. Then the losses that I talked, we are talking about 45% plus the battery loss, so we are talking about 55% losses. So it doesn't look very good. So since it doesn't look very good, what we are talking about, and I am showing another diagram, that solar comes with a DC to AC converter, it gets synchronized to the grid, and from the grid comes power like this, AC to DC converter, DC to AC converter. Part of the power of course can go from here, DC to AC to go like this. Part of the solar power can be used directly. So there the losses will not be 55%, the losses will be more like 20%. But a significant percent of power, because solar will fluctuate, so you can't expect it to do the load, it will go through the battery, and as soon as it goes through the battery there, you have 55-60% losses. That is where the problem is. 45% plus the loss of the battery. This is the 45% conversion losses plus the losses of the battery. That is where the problem is. So the first question that when we started looking at this and say, is there an alternative? Can we not do something? So we sort of said, well, what if I do something different? Solar is DC and I will directly charge the battery. I do a grid AC to DC converter and I will charge the battery, and DC to AC I put something like this. So I do a DC to DC converter. I don't convert solar into AC. Well, that should help, because DC-DC converter I may be able to design at slightly lower loss. So if I design it even at 10% loss, or even if I take 15%, I have 15, 15, 30 plus 10, 40%, not 60%, not 55%. So I get some advantage. So this is better, but what is the disadvantage? Now, solar power always reaches through the battery. Why? Because solar power I am never converting to AC except when it comes out of the battery. Earlier I was converting directly from solar, so if you look at my previous case, it could have gone directly from here to here. That would have been a route. Now I am not doing that. So solar power will always go through the battery. Similarly, even grid goes through the battery. Grid power which could have directly powered the load, which at least was okay, no losses. Suddenly I am saying, well, grid will have a AC to DC converter, maybe 15% loss, 15% loss, 40% loss, grid power will also have. So it's a bad solution. It's a bad solution. In fact, the previous solution is better, though the previous solution has larger losses. Solar and grid here cannot be used to directly power the load by bypassing the battery, even though the solar plus grid power may be greater than the load most of the time. I don't need battery, I want to be able to bypass it. I presented it to one of my students, he said, no, I think I can come with another configuration, and he came with this configuration. Let solar go to the battery with a DC-DC converter, and grid go directly. Now see, grid doesn't have losses. Nice. Solar only goes through this 15% plus 15 plus 10, 40%, so less losses. So looks much better. Well, yes and no. Grid power is now never used to charge the battery. So if I have a rainy day, my solar is not charging the battery and grid is not charging the battery, my battery gets drained off. Horrible thing. And in fact, actually grid gives grid power unless the power cuts are 20 hours. Huh? If grid power is 4, 5 hours, 6 hours, 8 hours, even 8 hours off, the grid power could have charged the battery and kept the battery all the time full. So that whenever power goes off, I could have used it. That was one of the objectives. No, I don't know. It depends on solar. I may be able to charge it, and suppose grid power goes off quite a bit and solar I start reusing it more, I'll get into trouble. My grid power could have charged the battery. It is so important. I want grid to charge the battery, I want solar to charge the battery, I want solar to go directly, I want grid to go directly, and I want both of them to go through the battery. And for that, whether I like it or not, the previous solution that I said looks like the only solution, except that it's a very, very high losses. At least that's a clean solution. So grid power is never used to charge. Solar always goes through the battery. I can't do still solar directly. See, solar directly would have helped me a lot. It is DC, one converter. I need not have unnecessarily, battery cost is very high. Remember that battery cost is 4 times, where as soon as I introduce a battery, I could have directly done. So these are all poor solutions. Much better solution is at least this, where if there is no power failure, solar and grid could charge the battery. So charge the load directly. At least that is not that much lossy. That part at least is not that bad. By trying to improve my power through the battery I'm actually worsening off something else. And in assignments, in fact, I give you many of these things and ask you to calculate, and you'll see that the only solution is this. So what is the option? First question was that came to me, hey, you are just talking this thing all over Germany, United States, California, people have used it. In fact, my sister yesterday called, we are using it, we don't find any problem. So I asked, what is your power? The 10 kilowatt. So obviously you don't have power problem. You are charging only 10 kilowatt in your home. One home is consuming 10 kilowatt. 10 kilowatt, and if it even for 5 hours is a 50 kilowatt hour. Our consumption is only 2.5 kilowatt or 3.5 kilowatt hour for an average home. So we have to do 1/10 or even less. So if you have, then the losses in the converters can be made 5%, and I can design it in such a manner that my total loss, including the battery, without battery of course losses can be very small. Even with battery my losses can be still 20-25%. I can design that. As soon as I start doing lower, and the second problem is there is hardly any load shedding. So most of the time you are directly charging. You don't know, battery is there only for rare situation, for maybe that fluctuation of solar. So battery is not going to be used much. You may put a battery, and so most of the time you are going to go directly. So now look at the solution. Now look at this solution, the original old solution. It goes very nicely. This most of the time, 98-99% time it will go like this and like this. Only this loss is there, and this I can make it 5 to 6% because I have 10 kilowatt. Actually works quite well. So West has thought about it, designed it. Batteries use only rare percent, 2-3%, 5% time. That doesn't matter. Losses are high. But in India, that is not so. Normally, solar power generation is less than required by the load. Infinite grid will always supply power. So that would have been. And they also have this reverse feeding, therefore. Reverse feeding is also important for them, because sometimes you may not be using the load, and solar you have put 10 kilowatt, you might, and 10 kilowatt you may not be using it. So reverse feeding becomes very, very important. In fact, in California, my sister told me that there's a big advantage that you can feed it during daytime, you get 40 cents per unit, and in the night time you consume it, you are only pay 10 cents per unit. So she said, I'll also be earning. Fine, that is works for in their country. Problem is when they come and sell it to us without understanding any of our situation. And people don't try to understand. We electrical engineers, we don't even try to understand. Professors also don't try to understand. Government doesn't understand. Government bureaucrats don't understand. They are only sold things, and then whatever else happens, they start imposing it. Let everyone use it, and everybody loses out, except those companies who sells things. It is this which sometime, since you are working in policy, this is what makes, boy, what have you done? Why have you not looked at different solutions? Is there no other solution possible? And it is here that our middle and lower income household will install power not even 1 kilowatt. losses will be very high. Grid feed through makes little sense. Everywhere policy is pushing to grid feed through. Why? Because the current units that are coming with grid feed through, so it has to be solved. Somebody has designed it, they are making it. So it has to be sold, and some local manufacturers have started making things without grid feed through. So to stop them, they introduce grid feed through. Every state government is going on. It needs a little bit of money to be paid. That you people know better. I'm not going to talk about it. We need something different, and that's what I'm talking. And that's the reason we went to solar DC. And this is something else that we found, that load is shifting to DC. Remember that my second class or first class itself, I talked about load is shifting to DC. Why not have a DC microgrid at home? And if you are going to have a DC microgrid at home, remember this is something new, not new. I have already presented this. If load is becoming a DC, my solar is DC, battery is DC, why don't I do what is called solar DC? Now look at this. This is the alternative called solar DC. Look at what this is. Solar is producing DC, in this case 48 volt DC, doesn't matter, you could do another voltage, but we have chosen 48 volt, and I'll tell you why we have chosen 48 volt a little later. So produces 48 volt DC, and this goes through an inverter-less. There is no inverter. There is no inverter, no DC to AC converter, because it remains DC. Only the grid power which comes as AC is converted to DC. Remember, because of that old Tesla, not the new Tesla, he pushed for AC power. So AC power comes, that's fine. Let's accept that. We'll convert that power into DC, and I'll make this efficient, because this is for the whole home. So it is not small unit for each place, whole home. I can design one things are quite good, and we have designed it with 5-6% losses. With tomorrow you may be able to design it. So one this thing they do. The solar, you don't convert to AC. Battery, you charge directly. You take power from battery directly and feed to the load directly. Suppose you do that. Everything is just, let's say, from here, just assume for a minute that 48 volt is coming, 48 volt is going in here, 48 volt is going out, 48 volt is going, only the grid is converted to 48 volt. Where is the losses? Well, there is a loss here when grid is converted, but that's a grid power. When grid is available, there is a loss. There is no loss here. Actually, there will be losses, but small. Well, the loss will be there. If it goes through the battery, the loss will be there at least 10% straight away. Remember that. If I'm using VRLA battery. If I'm using lithium battery, my losses will be less, but my initial cost will be very high. And I can do direct. See, I can do directly out here. Grid can do directly out here. Huge benefit. And you will see the assignment. You will see your cost of powering a home goes down by a factor of 3. Assignment problem. I have given you, when you go through the assignment problem, assignment has been loaded. Today you will solve one problem, you try to solve other problems. Highly efficient usage of power, low power from grid alone converted to AC to DC. I can actually do a total loss for the solar all the way coming here around 7% loss, plus of course battery loss of 10%, 17% loss. So that's not bad, 83% I can get. And hopefully I can improve that as I go further. That's a challenge for some of our friends, but at least that's not bad, instead of 45%. And if I go directly, maybe the losses will be only, from the grid there will be loss, maybe 5-6% loss will be there, but not that large. My overall losses go down, huge benefit. If my losses go down, my solar panel size will go down. I have given you an assignment problem for which I have done a solution and will do that. In an off-grid home, you need, your solar panel size goes down by a factor of 3. You will see your cost goes down so considerably for a small home center. This is what the advantage of something like this. So what's the advantage? Solar and DC connected grid power can directly power DC load when grid is available. When grid and solar can charge battery, battery is not full. During load shedding, solar power as well as battery can supply load, and excess solar power will always be fed to the battery. Highly efficient, Losses are small, not more than 7% plus battery losses. DC appliances itself can save huge energy saving. Remember that itself I get a gain of 50%. 50% I get a gain due to that, or 40%, 45%. Then another 20%, 25%. I'm starting to. That is what the solar DC advantage is, and you will see that where I take specific homes in assignment and try to give you a solution. But I want to point out that is not a trivial design, because after I have presented this almost for last year and a half, I've been talking about it, and people thought it's trivial, and it's not trivial. Why is it not trivial? Let me tell you, and there is a challenge. Of course, it requires good designer. Power electronics is key, you really need to design. Even when solar photovoltaic operates at 48 volt, first of all, I must get a solar photovoltaic to operate at 48 volt. If I take a 48 volt solar panel, it will operate only at 56 volts. Remember that, because MPPT point is different. Last class I talked about it. But if I take something which is, I design a special solar panel which operates at 48 volt, but during the day it varies. 48 can go 46.7, 46, 45, can go up to 49, 50, 51. Why? The MPPT point will vary, and with temperature it will further vary. So solar is not 48 volt. My load requirement may be at 48 volts. So what do I do? Similarly, the battery. Battery is voltage changes from 43 to 52 or even 56 volt if I want to do boost charging. A lead acid battery, when it is nearly empty, it's around 43, 44 volt. When it is nearly full, it is more like 52, 53 volts. So it is not the same voltage. So what do I do? I can't just connect 48 volt and everything to expect to work. So it requires very careful design. Of course, I want to keep everything at DC. You will require little small DC-DC converter. But remember, if you just blindly use DC-DC converter, their losses will be similar to AC to DC converter. You will not get advantage. So you have to really do an intelligent design, and that is what the inverterless has been done to minimize losses. The total loss, as I told you, in the kind of design that we did was 7%. I think it can be improved. It can probably be made 6% or 5%, where I can combine all these things, have a choice of combining all these things and do that. And essentially, I get what is called inverterless. So we designed this inverterless. Why am I calling it inverterless? Because you understand what an inverter is. Inverterless essentially doesn't have inverter, has a huge advantage. It has a solar panel which can be 125 watt, and you can increment it to 250 watt, 375 watt or 500 watt. Output will be 48 volt DC, 125 to 500 watts. You can have a battery all the way from 1 kilowatt hour to 5 kilowatt hour. You can connect it to the grid, 230 volt AC, up to 500 watts. You can take it from the grid. And you can, of course, also you have a Bluetooth, so that you can do prepaid, you can do all kinds of things. This is a system called inverterless that we created as first solar DC system. As I told you, that if you go from solar directly to the load, and we did two loads, one normal line, one emergency line. If you go directly load, loss is about 3%. If you go through the battery like this, and like this, and go like this, the loss is 7% plus about 10%, 17%. If you go grid directly, the loss is about 6%. If you go grid through the battery and come like that, maybe losses are again 8, 9, 10% plus 10% for the battery losses, 20%. It goes through the battery. Probably 18% is what I remember. So this is a system that is now starting to become available. I have installed it at my home, at my office, in large number of homes out here. We have today installed it in 1,000 homes, and we are now installing it in about 100,000 homes. Inverterless. And we have different systems. Inverterless are for off homes. We have connected number of off-grid homes in different parts of the country, and we are now deploying it in large number of off-grid homes. In grid connected home, it replaces inverter. Remember that in grid connected home, I have an inverter, it can replace it. It saves me huge amount of power. And of course, environmentally friendly, that's another advantage. Apartment of clusters, you can take a 4 homes together. You can take 8 homes together, 12 homes together, even 24 homes together. We have a same inverterless solution. Of course, size becomes bigger, but the concept is very, very similar, and you can give to each home what they need. That is the kind of thing that we have started. And today, for an off-grid home, of course, you can give power at a very, very low cost. And in an assignment problem, I actually ask you to solve a problem. And I've given you a home which is actually bigger than what you may not even use that much. I've given 2 fans, 2 tube lights, 2 bulbs, a television in assignment problem. It's a small home. If you need even less, then cost is going to be even less. In a grid connected home, if you are using inverter, it makes immense financial sense. Next time when you have to replace the battery, throw that out, start changing your appliances, because you'll really save and you'll also make the country green. Go to DC. If your apartment is in clusters, particularly if you're building new apartments, makes huge sense. Today diesel generator is used, you can get rid of diesel generator or use diesel generator only to operate lifts, and you can get very, very good solution, large financial case. A question that I'll just quickly go through, why have we chosen 48 volt DC? And if you see here, I'm also pointing out what is the kind of connector I have chosen. Look at this. This is a special connector that we have chosen. See this connector. This connector has a horizontal and a vertical. Why? Horizontal is positive, vertical is negative. Remember, it's a DC. You can't put it reverse. And if you didn't choose it carefully, somebody could have put it reverse. But by doing that connector, I am able to manage that well. Now, why have I chosen 48 volt DC? I could have chosen another voltage. Now, moreover, it is kind of known that under 60 volt, it's called safe extra low voltage. You can touch, and unless you are completely wet, and even if you are connecting to the ground, nothing else. In fact, actually, there is another interesting thing. The way we will do it is that we will not even bring ground. If you don't even bring ground, so even if you touch, even if you are wet, it doesn't form a full loop, and you are fairly safe. You are safe. Doesn't mean that you should go around touching. I'm saying in the worst case that you touch, it doesn't happen. You can't do that for any other 110 volt. Above 60 volt, you cannot do it. Now, why did you not choose 60 volts then? Well, 60 volt, remember, it can vary, and therefore 60 can go 64, 65, which can become somewhat unsafe. 48, even if it goes to 53, 54 volt, we are still much below the line. So next question is, why did we not choose 12 or 24 volts? Well, all of you know that losses in a line is I square R. So if I am powering the same load, if I am powering at 40, suppose I am powering 100 watts. If I am doing 48 volt, I have 2 amperes. If I am doing 24 volts, I have 4 amperes. My losses for 4 amperes will become 16 R. Losses for 48 volt will be 4 R. So losses will go up by 4 times. And if I choose 12 volt, the losses will go up by 16 times. 16 times. So basically a 48 volt DC is the highest possible safe voltage and also gives you the minimum losses. That's a very top level thing. Of course, you know, you get a landline telephone. Every landline telephone has a 48 volt coming to your home. You touch it occasionally, accidentally, it doesn't even really matter. You do that. You don't get to know about it. Electric vehicles are standardized. All telecom systems are 48 volt DC. So it's something on which there is a sufficient amount of experience. Power over Ethernet is 48 volt. It is a best voltage, a safe voltage. If you want to do low power, if you are doing up to 500 watts, which is roughly about 10 amperes, maybe up to 12, 15 amperes, this is very, very good. If you are doing much larger power, like you are trying to run an air condition, you have to choose slightly higher voltage. 48 is not good enough, and you are building the protection. Not that 48 you will not put any protection, you will put some protection, but it is not that problem is critical. And today we are building that. Solar DC inverter is the future for off-grid home, for replacements of inverters, and for DC power line at each home. And I'll giving a quote. This was an interesting article. Since you have this, you can look at this article. This article came recently, and the homes of tomorrow will run on direct current by Lloyd Alter. In fact, the home of today primarily runs on DC. We just have all these AC stuff running in between them. Very similar to the statement that I made in my opening class. Sasaram will be the first town in the world which all homes will be connected on DC, and the rest of the homes in the world will follow in next 10, 20, 25 years. We should take leadership here, and that's what we will do. This was one part. I want to take a few more minutes and talk about another very, very interesting innovation. And it came along with DC. What we sort of said that, well, to begin with, even as we are going to connect solar and all that, why don't I take a AC grid and put a AC to DC converter and have a DC line at home? Why don't we start? So that's how we started with. And then we'll say, well, as we started working on it, we can do some other magic. And I'll talk about that. First thing, all the technical and financial reasons why DC power lines make sense today. But what will happen? You'll buy DC fan, DC lights. Where are they available? It is new. People will say, let's not use it. It requires somebody to come and sell it to you and say, no, everything is safe, everything is available. It requires fairly large amount of push. What we want to do is create a market pull. Rooftop also makes a lot of sense. But again, what do you do? How do you connect to DC? If you are going to do AC, there's huge losses. After this lecture, at least you will not buy a rooftop AC system. So we need to create a market pull. How do you create a market pull? And we say, suppose each home is given an additional power line. So very simple concept we came up with. Suppose each home, there is a 230 volt coming in, single phase AC coming in. There is a meter that we have to go through. In the meter, I also put a AC to DC converter. And I give two lines. One is AC line, another is a DC line. DC line is at 48 volt. It is limited by what? Limited by my AC to DC converter power. So the maximum power it. Now what will happen? Suppose I give this line. This line is also available, this line is also available. So you are getting something extra, you are not being denied any. So as far as you are concerned, if you don't want to make any changes in life, continue to use this. But if you want to take advantage, you can take advantage of DC line. You can now put more energy efficient lights and fans and things like that, do some cabling and put that. So it does create a little bit of pull, but not that strong a pull. Why? Because yes, it is there, so I can use it, but why should I use it? Now suppose I do one more thing, and that's where UDC takes place. Whenever load shedding takes place, and load shedding, when does it take place? Whenever supply is less than the demand. So what will happen? You will select areas, you will do load shedding. So when load shedding takes place, what happens? The power goes. We will say, well, when load shedding goes out, AC line will go. Suppose I find that I can keep on making DC line continue to have power. Suddenly this DC line is uninterrupted power. How do I get it? If I have a load shedding, nothing will come in. Why should there be a power? And that's where UDC innovation comes in, an uninterrupted line. Now, if I can do this by some magic, then DISCOM is providing you an uninterrupted line. And I asked casually somebody, one of my peon, what will you do? He said, well, I'll at least buy one light, one fan. I said, but it will be expensive for you. He said, but my child studies. Without lights, cannot study. Without fan, we cannot sleep well. And gradually I will get used to DC appliances and I'll buy more and more. Then all these questions will not be asked because I'm getting uninterrupted line. Not just because of power saving. I get power savings, but I also get uninterrupted line. The question is, I'll keep on adding till the line takes no more. And if the line is full, because I allow only so much power, if I try to put more power, it gets cut off. Then what will I do? Well, and now I can add solar to this very nicely. No? There is nothing to prevent me to add solar. So to this line, I can add solar panel, because it's a DC line, very easy. Remember that all the losses go low, all those advantages that I talked about will be there by if I do that. So solar becomes excellent investment. Instead of trying to let my investment sit in a bank and give me some return, even if it gives me 8% return, 8.5% return, I have to pay tax on that, so I get only so much. If I invest in this, it will save my power bill and I will get much higher return. And gradually I will replace all my appliances. So I have created a market pull. How is this possible? Well, very simple concept. As I told you that you are continuing to power this, and this will give you a limited power DC. But whenever the power cut takes place, what you are doing is you are introducing a concept of 90% power cut instead of 100% power cut. And whenever load shedding is cut off 90% of power compared to 100% power in the conventional system, something we call brownout. Let 10% power continue to flow and let that 10% power come to this. This gets cut off. That is the innovation. We did this, look very different kind of thing. Load shedding is now not 100% but 90% power cuts. We first tested it in IIT, then we tested it in several substations. Everything is working, and today when we are going on connecting to Sasaram DC homes, this is we are going to put in every home, and we are going to put in several towns in Bihar and in Assam. And well, there is a signaling that is carried out, doesn't really matter, I don't want to get into it, and essentially that is detected to cut off this line, and whenever power is restored, you get connected again. This is the UDC innovation. So as a result, you have created a market pull for DC line, you have created a market for solar. So this is my last slide, not bad. Solar DC is the way to go. Have a DC microgrid at home and small offices, and have solar and battery directly connected to the DC power line. If there is no load shedding, that's fine also. You get anyway the advantage, but the load shedding the advantage is more. Use DC powered high energy efficient DC appliances, gradually become a DC green home. Add solar, will save huge on its, and UDC innovation creates a market pull. Grid fed limited power DC power line at home gives a DISCOM to get market price for AC, and this is what happens. So essentially that is what I was going to do, and I pretty much done it in 1 hour. I know it was a little fast, but hope you have understood it, and I want to end this lecture and I want to ask you 2 questions. First question is, and which class I am seeing? GCT, Coimbatore? Is it Coimbatore? Are you people there? Could raise your hands. GCT Coimbatore? Yes. So I am going to ask questions. See the question number 1. You have to answer A, B, C, D. How is inverterless solution better than the existing solar AC system? First, answer A is avoids AC DC or DC AC conversion. B is it is a more energy efficient system. C is highly efficient when dealing with low power wattage. D is all of the above. Which is true? And you can say whichever is true, you can say it avoids AC DC DC AC conversion. Is that true or not true? Yes or no? Raise your hand if you believe that. Most of you don't believe that. In this place, well, several people raise the hand. It is a more energy efficient system, a solar DC, inverterless solution. Is that correct or not correct? Raise your hand. Those of you believe that. Oh, everybody believes that at least. Highly efficient when dealing with low power wattage. Is it true? When low power wattage, it's highly efficient. And so all of the above. So answer is yes, answer is all of the above. So all the answers are right. A, B, C and D. It's not just D, all the answers are right. Easy question. Second question, how does UDC system overcome transmission losses usually found in DC line? Does it install a new DC line at every substation? Substation to home, does it put a DC line? Yes or no? Anybody who believes yes, raise hand. Otherwise believe no, don't raise hand. So nobody believes that there is a new line. Use existing AC line from substation to DT, and DT is the distribution transformer, and put a DC line from distribution transformer to home. Is that correct? Somebody says yes, raise your hand those who believe that. Nobody believes that. Using the existing AC line from substation to home and having a DC line only at home. Yes or no, those who believe that, raise your hand. I do see today most people are able to give the answer right, and all of the above is not true, of course. That's obvious trivial question. If C is right, then all of the above is not true. Well, I am going to stop here. That's the right answer, and we'll stop here and ask you to ask questions, and if you have questions you can ask questions, and after that I am going to, you can raise hand and ask question. If GCT Coimbatore wants to ask question, they already have the mic, they can ask question. Anybody else, raise your hand and ask questions, and after that I will go to the assignments. Anybody can ask questions, even this class can ask questions while we are going on. I'll repeat the question. Any one of you have questions? Yes. So inverterless can have grid, can have solar. So both are become the primary source. Now it depends on home to home. You can connect both and then both will have. If you go to a place where there is no grid, it is only solar. When you have connected to some place where you have not connected solar, you have only put grid, then it is only grid. It can have any combination. All combinations are possible. Grid alone, solar alone, grid and solar together. Not upon us. Market is providing DC appliances. Today there are different people. We will of course make it available. We'll let people know where they are available from. It is new, but it is starting to become available, and over some time it will be widely available. So DC lights, DC fans, DC cell phone chargers, DC televisions, all these, and tomorrow DC coolers, all these things are available, are becoming available, and initially of course that's a little difficulty. We will try to get it in, but soon it will be available widely. Yes. So question was that are they requiring only DC appliances? In the inverterless, we will provide a provision that an odd AC device can be connected using a DC to AC inverter. That will give as an option, but that's only a limited option we'll provide. If you are connecting a 500 watt solar panel, we may allow up to 125 watt of AC. So we are going to provide that, so that it can be odd, but the whole idea is to convert to DC. We want you to convert to DC, because that alone will save energy, will give you benefit long term, that will give you higher efficiency, that will make the country green. So that is the whole idea. We want it to move to DC and not to continue using AC. Any question that any other person has? Yes, please.
Sir, good morning.
Yes.
You said that we want to standardize the DC voltage at 48 volts.
Yes.
If we talk about a charger, so it requires 5 volts DC, and the laptop requires 18 volt DC. Means for charging these devices, again we require a DC-DC converter. So will it not have the loss coefficient into account? And second point is.
Ask your second question.
Second question is. We are converting AC to DC, and we are connecting the solar panel directly to the DC. As you said, that we need to standardize the voltage at 48 volts. So, and we will be connecting to DC. At the same time, can we also connect the batteries exactly at the same point where we are connecting the solar panels, such that we can have a standardized 48 volt DC? Because even though when AC power fails, then we can use the battery backup power as well as the solar DC. Thank you.
Yes. So let me start with your second question first. What you are saying is correct. In the inverterless, there is a small circuitry inside, but we are connecting solar panel directly. We are connecting battery also, all at 48 volt. So you get a 48 volt solar panel, 48 volt battery. The voltages will not be exactly 48. It will vary all the way from 45 to 51, but that's fine. We adjust it internally in a manner that you can connect solar panel directly, you can connect the battery directly, and you can actually provide the power. So that second question is, as you what you said was right. You can connect on inverterless. You can connect. If you are interested, come and see what we have done at IIT. The systems are now starting to become commercially available and will be widely available soon. Your first question, I think, is a very interesting question. Today, laptop uses 19 volt very commonly, 19.5 volt. But laptop doesn't use 19.5 volt inside. It converts 19.5 volt to 5 volt, 3 volt, 2.2 volt, even 1.8 volt internally. That's what the laptop will do. If 48 volt becomes standard, they will have no problem in taking 48 volt and converting all these things internally. Till that time, we will have to design a very highly energy efficient DC-DC converter, 48 volt to 19.5 volt, and that will be a problem. But like for example, televisions also are electronics. Internally, they are converting 230 volt first. In fact, most of the time they convert closer to 48 volt, and then they convert to the voltage that they need. So it is possible tomorrow to get a 48 volt input directly, and then there is always multiple conversions. No electronics works at single voltage. So the idea is that if we can standardize 48 volt, most of these people will take 48 volt input and convert it internally. For the time being, we may have to design some efficient DC-DC converter. So that will be a little problem. We will do that. But remember, lights, fans, coolers, and things like that we have designed directly at 48 volt. The second important thing will be USB. USB is going to be at 5 volt, 5.2 volts, and we will need a 48 volt to 5.2 volt converter, and that will be again a DC-DC converter, and there will be losses, and that's not a very highly desirable thing, but it is possible for us to do a single conversion at a place and do a multiple, if in a office environment, in a home environment, connect multiple such USB together, group them together, then you can make them reasonably efficient and not that high cost. But yes, you will have to do this. I think USB will still always be important. 19 volt may go away, may not be as important. It may get the input directly from 48 volt. But I do see that USB is going to be important. So you will have to really look at how do you convert it into 48 to USB. I think it's an extremely important question. This is the biggest dilemma that we have. But much of your high power consumption, even all your television and things like that can, or even laptops can actually move to 48 volt. Remember that we are finally going to rely that that 48 volt to 5 volt. Anybody think which consumes 5 volt is actually consumes very little power. Okay, but an interesting question, and this is a big dilemma. So I think I'll stop here. Now what I'm going to do is I have given you an assignment. I don't know how many of you have looked at the assignment, a tutorial. It has about 3-4 problems. Some minor changes we will make this week. I'm going to take first of the 3 problems and try to solve that. First, before I do that, let me give you a little bit background. Inverterless usage scenario, going beyond benefit to the nation. There is definitely benefit to the nation, but we want to look at what else is there. So my outline of this which is more of a tutorial kind of thing, is I look at new installation in off-grid homes. So one of the problem is off-grid home assignment problem. Then new installation in connected multi-storied complex. So one of the problem is on calculations for new storied multi-storied complex, and retrofitting existing mid-income home having load shedding. So one problem is associated with this. So I have given you different problems associated with this. As you solve them, you will find the benefit of that. What I will do, economically obvious for all new builds, you replace 5 ampere line with DC line, DC appliances and all that. That's the best way. Solar to the extent possible on the rooftop, battery backup where load shedding is likely, can have a small AC power. That's a question that you had asked for legacy appliances. Small increment in capex saves power immensely. You can replace them one by one. You don't need to replace all the appliances together. And that 15 ampere line be also there with AC line. So you just change the plugs. You can continue to use the 15 ampere line. 15 ampere line itself comes with dual plug. You can always use that for even some low power AC devices. So the first thing is retrofitting homes having load shedding. Replacing inverter with inverterless, maybe wherever the battery needs replacement. And solar will always help. It's a better investment than keeping money in the bank. And appliance replacement costs are recovered in a very short time, sometimes even less than a year, by saving on the power bills, much less than a year. Higher load shedding means you can do it in next few months. You will see answers. In 3 months you can recover. It is a high load shedding. So if load shedding is not there, it takes a little longer, but even then you can actually recover quite well. Before we begin, let us look at various things. Let us take typical AC and DC homes. AC home where there are AC appliances, DC home where there are DC appliances. So AC and home and DC home doesn't depend on the supply. It's the appliances, what appliances are there. So let us make a list them. Let's look at the cost of each one of them. Let us look at typical appliance usage per day. How many hours do you use? And later on we will also give you problems. I'll keep on adding problems. I'll say this appliance you use it more between 8 to 9 PM and this you use more between 11 to 12 AM. What are the losses in different scenarios? I'm going to talk about losses in different scenarios. And power costs from different sources. And what is the load shedding that you can get? You have to have these as inputs. And what I am asking is, given all these input, design a nice Excel based simulator, which can give us these as inputs, and then it can start giving you output whatever you want. Let us take typical homes. I have taken first appliances, home appliances. So look at the appliances and I have listed here what is the power consumption. Take a fan. Fan can be AC fan or a DC fan. Now AC DC fan can have 5 speeds, 1, 2, 3, 4, 5 speeds. So if the 5 speed AC fan consumes 72 watts, DC fan consumes 30 watts. If it's a speed 4, 69 and 25 watts. Speed 3, 66 and 20 and speed 160 and 10. And I have given the cost. Remember the cost question was asked, typical cost 1400 rupees and 1600 rupees plus taxes may be there. A tube light. Take a CFL tube light and a LED tube light. A 36 watt as opposed to 18 watt. And you can dim them. You can reduce the intensity, which you cannot do with CFL. Very easily you can. So you can consume less power. And CFL tube light will be between 225 to 300 rupees, depends on what you buy. And this will be around 700 rupees. A bulb. A typical bulb AC will be, let's say 40 watts, could be actually 50 watts. This will consume only 5 watts LED. Cost is maybe 60 rupees and 110 rupees. I don't know the exact cost. You may get it cheaper, but I don't think so. I've taken a television, a small television, 24-inch television. I can of course take a larger television, but I've taken a small television in this example. 40 watts and 30 watts. I'm not even taking set-top box. I should have taken set-top box also. It is actually television plus set-top box. This may be more than 40 watts. A typical cell phone, 6.5 watts or 5 watts. A laptop, 60 watts if it is AC is used, DC is used around 45 watts. Air cooler, the desert cooler, what we call. In dry climate only it can be used, cannot be used in Chennai. Small one, 250 watts, we have taken 100 watts. And here also we can do speed, 250 watt can become 230, 210, and here 150 and 25. So again in AC, if you reduce speed, it doesn't reduce power too much. In DC, it significantly reduces power. And I have taken different kinds of homes. A small house, large house, and multi-storied flat, small flat. I've taken that a small home will have 2 tube lights, 2 fans, 2 bulbs, 1 phone and 1 television. Now one can change those numbers. You should make it in Excel and you can change those numbers. Large homes on the other hand, they are not really large homes, more like a middle class home. Large homes are much larger. It should be mid class homes. 6 tube lights, 6 fans, 6 bulbs. Typically you may have a 3-bedroom apartment, 3 fans there, plus maybe a couple of fans in the living room, 5 fans, 5 or 6 fans, 6 tube lights, 6 bulbs, 1 air cooler may be there, I've added here, 4 phones, 2 television and 2 laptops. And in multi-storied complex I have taken typically, these numbers are inputs, you can change them. You don't like, you want to take your home, you can put your numbers. What is the operational hours per day? This is extremely important. How much do you keep the tube light on in a day? Average is 6 hours you have put here. You can change that also. A fan you may keep it longer, both in the daytime as well as in the evening and the nights. Bulbs you may keep it for still longer, you may keep it. Air coolers depends on where you are, you may use it for 7-8 hours as much as that. Phones I have to be charged, so 4 hours is more than enough. Laptops maybe 5 hours and television about 10 hours. Now you can change those numbers. So these are important numbers and they are, your problems are all dependent on these inputs. Now what are the losses? If I take a grid power and I connect to a DC load, I'll get typically about 6% loss. If on the other hand, if I take grid AC and connect to AC load, I get 0% loss. So there here is this one thing that I have advantage. This is like AC power directly. So I get 0 and 6%. But if I take solar panel and connect it directly to DC load, I get 3%. But if I take solar panel and convert it from DC to AC and do, now I have losses of around 18%. I am taking small panels, under all assume under 500 watts. Take solar and mains without battery. So solar and mains I am combining, grid you are converting to DC, this you are using DC directly and DC load. And if you see solar loss is about 3%, grid losses is 6%, same as what you got earlier. And if I take AC, solar losses becomes, because there is a AC to DC converter, is about 18%, grid losses is 0. Grid losses is 0, remember that. If I now use battery without solar, only the grid or the mains and the battery. Of course, if I use DC, then I do a AC to DC converter, I get some losses. That's the same as what I was getting earlier, at 6% losses. But if I go through battery, I have to do AC to DC converter and then charge the battery, I'll get about 15% loss. Now there is battery loss of 10%. Going out you will not get any losses, or practically negligible losses, maybe more like 11-12%, but that's a typical loss. Losses through battery is put as X% plus Y%. X% is from source to the battery and Y% is from battery to the load. Now, these are all important parameters. Similarly, if I take from grid to AC load, now I have to do a DC to AC converter, battery and AC to DC converter. So I get 15% loss here. Here I get 10% due to battery plus 15% due to conversion, so 25%. Now if I take solar and go through battery, if I go directly without mains, there is remember I can go directly a DC-DC converter to battery and then I get this. So here I get about 5% loss and I get 10% due to battery. I'll always get 10%. If I connect to AC load, then I can still do this around 5%. But here I'll get 5 plus 10, 10 plus 15, 25% loss. But this is if I don't have mains. If I combine mains and solar, problem becomes more serious. If I do that and if it is connected to DC, I get about 5 to 6% losses out here. So if I connect grid to battery, because I make a battery charger, I may still get about 15% loss. From solar to battery, I will get only about 5% loss. From battery to the DC load, I get only the battery losses about 10%. What if I use AC? Then I have more losses, no losses here. Grid can go directly to AC. But if I go through the battery, solar, if I do 15 plus 15, 30%, then from battery 10 plus 15, 25%. So 30 plus 25%. If I do grid, I get 15 plus grid 15% and 25% outside. That's a typically losses. Now what I have done is that I have summarized all these losses here. Through battery, without battery, solar, whatever I had done, I have summarized this. This table becomes important. This needs to be entered. Of course, these need to be entered as source to battery and mains to battery and solar with mains. So here you have to take into account whether it is a solar to battery and battery to load. So you have to split them into two fields. What is a typical load shedding? Well, it varies. I have taken one case where the load shedding is only 4 hours. 2 hours during sunlight, 2 hours during off sunlight, 2 hours when solar is there. So if the load shedding is there, if solar is there, you can power from solar. What is the load usage? Well, again it will vary. I have just assumed here during sunlight, I assume 40%, 60% load is during evening hours. What is the cost? These are more closer to grid cost is 5 rupees. Well, it depends on if it is an industry or if it is a office complex, it may cost 7, 8, 9 rupees today in Chennai. Solar DC cost is only 4 rupee, maybe 4 rupee 50 paise, 4 rupees 25 paise. Battery will add 12 rupees more. Remember the battery, there will be charging cost plus there is a cost of battery, 12 rupees more. And solar AC will cost about 6 rupees. Now based on this, the question that I am asked, there are some assumptions that I make. If solar is installed during sun hours, sun supplies full load, solar supplies full load. Power cost is the total power usage plus multiplied by 1 plus solar to load loss plus solar cost per unit. If grid is there, grid supplies full load and the power cost is total power usage into source to load loss. This is grid to load loss into mains power cost per unit. If suns and mains both are not there, then battery supplies. For off-grid operations, solar supplies. For on-grid, grid supplies. And I have actually calculated what the power cost will be. Power cost is a total power usage and that is from the battery, total power on the load, 1 plus battery to load loss percentage into around 12 rupees. Remember 12 rupees is what I had taken there. Plus the load from source to battery and battery to load loss 1 plus this into source cost per Source can be mains or solar. So this is the kind of expression that I need to use when I do this. And the question that I've asked, use an Excel sheet, learn how to do this on Excel sheet. It is not going to be easy, but it's going to be extremely interesting challenge. The question is, consider a small household. Load profile was given in slide 7. Build Excel sheet to compute. How much will be the load consumed per day in watt hour? Assuming that AC homes, and next assuming is a DC home. How much will it cost if it is all grid power without any power cuts? There is no power cuts. Compute the sunlight and the non-sunlight load separately. What percentage of power can be saved in DC homes vis-a-vis AC homes? So this was the first question, and I'll skip this now, and this is the answer. You design an Excel sheet, all the tables that I have given, put that as on one sheet as assumption, costs or assumptions, and in another sheet you now calculate what is the power consumption in AC home and what is the power consumption in DC homes. And of course, number of tube lights are 2, 6 hours a day, wattage is 36, so watts will be 2 into 6 into 36, 432. This is assuming that for DC system it is only 18, so 2 into 6 into 18 is a 216. This is for AC system, this is for DC system. Similarly for fans, 2 fans kept for about 12 hours, 72 watts. I have taken all as full power. My power consumption is 1728. In DC it is only 720 watts. For the bulbs, again I have taken the power 10 hours, 40 watts, 800 watts. Here I have taken 5 watt only, so only 100 watts. Television, I have taken number of operational hours I took only as 4. I think it was changed, not 10 hours. And wattage is 6.5, it came to 26. And here wattage is, so this is 4, yes, 4 hours, so that's all right. And television is about 10 hours. I have taken 40 into 10, 400, or 30 into this is 300. Plus there is a losses of 0% here and 36% here. Taken losses into account. So I don't know whether I took the losses calculation or not losses calculation, but the power consumption with losses is coming to 3386 and 1437. So in fact, if you take the cost of the mains with losses with 0 load shedding, it is 16 rupees 93 paise per day as opposed to 7 rupee 19 paise in DC system. So more than 50% saving, almost 55-56% saving. Cost saving per day is 16 minus 7, 9 rupees per day. So almost more than 50% saving. So just imagine, in 1 month you will save about 9 into 30, about 300 rupees, close to 3. This is assuming 0 power cut. Remember, I told you 0 power cut is always the worst situation. In 1 year you will save 3,600 rupees and your tube lights, fans and bulbs will not cost you more than that. So you can actually do huge, even if you don't take phones and television for the time being, that differential is small. This 3 tube lights, fans and lights can do a major savings. You can do that, and that is what you can do in this. Now what I did in question number 1, 2. So if you look at 2, second question was, if AC load is to be fed from the grid alone with battery backup, and we are assuming 4-hour power cuts. Assume 4-hour power cut. Remember 4-hour power cut we had assumed. What is the, now it goes through a battery, so you will require a battery. What is the cost? Then repeat the same thing for DC. So 1.2 and 1.3 is what I will show now the result. So if I now assume 4-hour power cut. Home on grid with 4-hour power cuts, 4-hour load shedding. I have assumed uniform load assumption. The load is uniform throughout the day. Of course, if it is not uniform, you have to do that calculation becomes an what is the load profile you take. So I have taken uniform load. Power consumptions during sun hour come to 1354, power consumption non-sun hour comes to 2031, and in a AC case, load required from grid comes to this much, from the battery, because there is a power cut for 2 hours, 282 and all that, and therefore the total battery power is 564 hours, total grid power is 2821. I calculate this cost, this comes 12 rupees 42, this comes 14, and total comes to 26 rupees. 4-hour power cut suddenly increased the cost from previously it was only 16 rupees per day, now it has come to 26 rupees. I have taken the cost of the battery, etc. and solar wherever we do that. It comes to 26 rupees. What if happens if I repeat the same thing for DC? For DC I do the same thing, my cost is only 11 rupees. Remember earlier my cost was 7.19 rupees. So here also I pay 4 rupees extra because there is a 4-hour power cut, but only 11 rupees per day. My saving therefore per day becomes almost 15-16 rupees now. 500 rupees I will save in a, and this is only 4-hour power cut. 4 hour and no solar. I am not yet using solar. Solar will make it even better, more interesting. Just imagine 4-hour power cut, 2 hours in the evening, and suddenly I will save 500 rupees per month if I use inverter less rather than and change my profile. And this is assuming that loads. Remember that I can change those loads. Now let me take off-grid home. If a system is a solar AC system being fed by N into 125 watt solar panel without grid, there is off-grid home. You take 125 watt into 4, 5, 6, 7, whatever you require, that much solar panel. What is the total power cost per day and what is the battery size? Again, I have done the Excel sheet for this, and the cost comes to very, very high, 56 rupees per day. There is no grid. There is no grid. If there is no grid, solar has to power the whole of battery. Night time solar is not there. If solar is not there in the night time, what happens? Whole thing has to be powered by battery. It's like almost 12-hour, 14-hour night time, 14-hour night time power cut. Earlier there were only 2-hour night time power cut. Remember that. During daytime I am assuming solar will supply it. My solar size, I am not given here solar size. Yeah, solar size is, no, this is not correct. Oh, in AC case, yes, AC case, it is 1 kilowatt hour of solar power panel. I have to put 8. So that also will become. Battery size will become around 5 kilowatt hour. Again expensive. And that's the reason my overall system is going to become very expensive. And that is just to power 2 fans, 2 lights, 2 tube lights, 2 bulbs, 1 cell phone charger and 1 television. Of course, if I cut down some of this, my cost will come down, but 55 rupees, 56 rupees in 30 days, about 1700 rupees. Remember, you are going to off-grid homes. Where are you going? People who have no money. Huh? And that's what the government does. It goes and puts these programs. You may say you're giving subsidy, but finally that's a cost. It's here. What happens? My question was, what if you do the DC system, solar DC system, N into 125, same thing. What happens? This is the numbers now. From 55 rupees, it comes down to 17 rupees 72 paise, higher than 11 rupees. But remember, we are talking about 14 hours power cut. 1/3 the cost. 1/3 the cost. This is what I have been repeatedly pointing out. Your solar panel size goes to only 375 watts, approximately 1/3. Now, the reason it here I have taken only 125 watts, so I can't do 350 watts. I could have managed with 350 watts. I have to do 375. It gives me a little bit of surplus, which is not bad. For a battery, it will be better. And battery I have taken about 2 kilowatt hour, not 5 kilowatt. And this is good enough. It's a decent home. 2 fans, 2 lights, 2 tube lights, 2 bulbs, 1 television, 1 cell phone charger. Now the cost is not that, still high, 500, 550, 600 rupees. But remember that this is not what we are putting. And the cost of appliances, if they have no electricity, they had no appliances. So anyway, they will have to buy those appliances. It will be roughly the same, only minor difference. And yet every government is going on pushing for the solar AC system. The question number, last part. If system is solar DC or AC being fed by 125 solar panel, I am assuming grid and battery both are there. It is not properly framed. We will reframe that question. Grid and battery both are there. Now grid and battery both are there. And I am taking a AC home, grid is there plus solar panel. This time solar panel is only 125 watt. Why? Because I don't need more, because my grid is there, only 4-hour power cut. I am going back to my 4-hour power cut. If the power cut is larger, then I have to think about something else. Plus a battery. Battery charged from the grid. I have not put here the battery size. I should have put, I forgot. Well, battery size is not that bad. Battery size is going to be small here. But the important thing is, if grid is also there and there is a 4-hour power cut and I put solar of 125 watt, then my cost is only 22 rupees 72 paise. Now remember, when I didn't have solar, just grid plus battery, my cost was 2652. So solar always helps. Solar brings down the cost. I have only 125 watt solar. That's the only change that I made. Rest is same. Calculation becomes more complex. So from 2650 I come to 2270. 4 rupees it comes down per day. So 120 rupees I'll save. And I've taken the cost of solar into account. My battery size also goes down, solar also goes down, grid with 4-hour power cuts. Now what if I do DC? Remember, if I did with DC with just 4-hour power cut, my cost was 11 rupees. If I now put solar with DC home, it comes down to 8 rupees 50 paise. Much more affordable. And I have taken the cost of solar and the battery, 250 rupees. Maybe 260, 270 rupees, and 4-hour power cut, doesn't matter. Remember, this is very good. 250, 260 rupees, 4-hour power cut. I mean, in big cities, that's pretty much what you get. Some places you may get worse, that's a different thing. When we can do, we can just not change things. In fact, I have done extra problems yesterday of doing 6-hour power, instead of 4-hour, 8-hour power cut, 12-hour power cut, 16-hour power cut. I have done all of them. But otherwise, this is all that you get. I have summarized the results out here. But I want to put the challenges and end by saying, this is what I want you to try to see. And one of the teachers there asked the question. One is, can I design a 95% efficient CFA inverter, 48 volt to 230 volt AC, only 150 watt. I'm not even looking at larger one. With less than 1,000 rupees bill of material. Maybe bill of material. That's the cost of components. Maybe 1,200 rupees. Maybe 1,500 rupees. I think this is a very, very interesting, challenging problem. In fact, I almost call it a near PhD problem, but a good project problem. Taken another one, 48 volt to 12 volt. Remember, this is a question that was asked by one person. 250 watt converter with 93% efficiency. Can I design something like this? These are kind of challenges that we will come across in India. These are our problems. Remember, nobody will design it for 150 watts. They will design for large. Design, and can we actually make it? Bill of material should be low. Can we design something like that? Even for the next one, your bill of material will be what? Maybe even here we can assume 1000 rupees. These are kind of problems that we really need to stop it here because it's. So anyone has questions and answers? There are some colleges.
In the system that you have drawn on the board, where you have a meter and the AC/DC converter, will we not have power quality issues there?
No, it has been designed to take care of all the power factor issues, and even if there is a power variation out here, you get a standard 48 volt DC. No problem. This has been designed with all these things being taken care of. If you visit IIT Madras, come and see. These are not too difficult to design. It does take a little effort, but it has been designed and this is available now. Did I answer your question?
Thank you, sir.
Thank you. There is another, nobody else? Some BMSC only, again, Morgan. Anybody else? Here, any question? And we'll end after that. Voltage regulation concept, we are using wind energy to regulate the grid failure and battery charging. Then why it is required to use solar DC? Well, solar DC I have talked about. First of all, I have talked about why DC is important at homes and offices. If you use wind energy, you again get AC only. Why is DC important? Because it saves power. Number two, why is solar important? It can be done on every rooftop. Wind cannot be done on every rooftop. And that's the reason solar DC is important. Wind is still centralized concept. Okay. I think that's a question that I have. Any other question? I think that pretty much is the question. I think that question I already answered. How 10% low power DC can operate all home appliances? 10% will not operate all the home appliances. It will operate some of them. First of all, of course, DC appliances consume less power. So typically 10% will operate 2 fans, 2 lights and a cell phone charging. Or you can shut off 1 fan and put a small television. But you can add to it, not by adding solar. You can make it as all appliances if you are willing to put in a little money for the solar. So that's the answer. I think with that, I think the 6 hours I'll stop, and I hope you learned something, and maybe some other time do some more. Thank you very much.